welcome aboard. Today we're diving deep into the fascinating world of Anthropic's newest sensation, Claude 3, and how to harness its power in machine learning pipelines using the open source Kubeflow framework. Throughout this adventure, we'll be unveiling various parts of the Kubeflow pipeline, giving you a first-class seat into how these complex pipelines actually come to life. Our ultimate compilation target is a Kubeflow pipeline specification, which can be run on popular platforms like Vertex AI Pipelines. However, you're free to run your pipeline solo or on a different cloud if you wish. First, let's enable the required APIs. Next, there's our desired service, Vertex AI Pipelines. Our mission now is to compile a Kubeflow pipeline specification, pre-populating some fields. We'll create and populate this specification in an IDE of your choice. Together, we'll create our pipeline.py file. From data fetching to inference, our pipeline steps can be easily defined using the Kubeflow Pipelines Framework's DSL library. With the DSL component function decorator, we'll suggest a base image like Python 3.11 and include the essential packages. We'll import LangChain and Wikipedia into our component and develop a task that takes a concept as a string and outputs a long summary of that concept. We'll use this Wikipedia data for a cloud-based translation task. We'll write our output artifact to cloud storage, effortlessly specifying the output path on Google Cloud Storage. Everything compiled successfully, and we now have a ready-to-go pipeline specification. But we need a cloud storage bucket, so let's create one, setting it up in a single region for cost reasons. Let's check that our new bucket is ready for our pipeline specification. Moving on, let's pivot back to Vertex AI and initiate this import from our cloud storage specification. Fields get pre-populated following our specification. We aim to run in US Central 1, specify an output directory, and a concept. Let's confirm there's a Wikipedia page on Anthropic before integrating it. Our task is to have the cloud execute long context translation or styling on this page. Let's view our first pipeline run. It's looking good. To recycle work, we'll use the caching system for our first task, which is especially important for expensive ML APIs or long-running steps. For a fun next step, let's further refine our pipeline. We'll recycle elements requiring only the Anthropic library and an input artifact from the first pipeline run. Maybe we could translate the Wikipedia summary into pirate speak. Still a lightweight translation task, but more fun. We'll borrow example code from the Claude project's GitHub page. Be sure to log in and have an Anthropic API key ready. We read the artifact's contents into memory before writing it out as a string. The output is written to its artifact, stored and versioned safely in Google's cloud storage. By leveraging Kubeflow's artifact system with inputs, outputs, and dependency inference, the translate task is implicitly recognized as reliant on the Wikipedia entry task. The initial task is unchanged, so we can rely on the caching system. We hit another issue with the output as a list. A Swift code update is needed, then we're running much smoother. We're again rewarded with a successful run. Let's review our final output in cloud storage, our pirate translation of the Wikipedia text. You can find the Python code and diagram in the video description, and we'll monitor the comments for any questions. Thank you for watching, and please enjoy responsibly.